Jai Gurudev, happy day children. Hope so. You all are clear in the previous chapter, rational numbers. I think you all have completed your worksheet and assignments of the rational numbers. Next, we will go for an interesting chapter. I know you all are very eager to know the chapter. Before that, we will go for a rapid fire test and then we will see the next chapter. Children, I will remind you, you should not use pen or pencil. And another thing, I'll be very fast in the question. So, try to answer. First question. Subtract 10 from the biggest 3-digit number. Then add 11 with the answer. Next, half of the answer. Next, again half of the answer. Next, subtract 230 from the answer. Next, add 2000 with the answer. Yes, children, I think you got it. Finally, you will be getting the answer, the year in which we are. Okay? Yeah. Children, today we are going to see the concept, actually the representation of numbers only, how to represent the biggest number and smallest number in one number. I think you have guessed it. Am I right? Yeah. We are going to see the new chapter. Let me see. Yes. Today's chapter is powers and exponents. Children, can you count the number of stars in the sky? Or can you imagine the size of an atom? Yes. One is definitely large and other is infinitely small. So, it is difficult to comprehend or visualize such numbers. They are cumbersome to read and write. Simpler ways have been devised to express very large numbers or very small numbers in a convenient form. This is known as the exponential form. When such numbers are expressed in the exponential form, they seem easy to comprehend. For example, 6 into 6 into 6, where 3 times 6 is repeated, which can be represented as 6 to the power 3. We can read this as 6 raised to the power 3, where 6 is the base and 3 is the exponent. Children, so far we have been dealing with positive exponents. Let us now find the value of the negative exponents, that is, the numbers that have the negative powers. To find the value of a negative exponent, please observe the following pattern. First, we have taken 5 cube, that is 5 cube equal to 5 into 5 into 5, which is equal to 125. Yes, right. After that, I have reduced one 5 here by dividing the 5 with 125. So, 5 squared equal to 5 into 5, 2 5s, which is equal to 25. That is, I told the pattern is followed by dividing with the answers, dividing 5 with the answers. 125 divided by 5, where you will get 25. The next, 25 divided by 5, that is 5 power 1 equal to 5. We know that 5 power 1 equal to 5, which is equal to 25. The previous answer, 25 divided by 5, which is equal to 5. In each step, you should divide the answers with 5, so that finally you are getting 5 power 0 equal to 5 divided by 5, which is equal to 1. Okay, now you got 5 power 0 is equal to 1. These all are positive exponents 5 power 3, 5 power 2, 5 power 1, finally 5 power 0. We got the answer as 1. Next we will go for the negative exponent 5 power minus 1, which can be written as 1 by 5, because 1 is the previous answer and this pattern we are following the division of 5, so 1 divided by 5. After that 5 power minus 2, which is equal to 1 divided by 5 is the previous answer. And what is the pattern, children? Yes, we have to divide by 5. So 1 by 5 divided by 5, which in turn we will get 1 by 5 into 5. That is 1 by 5 divided by 5. Here 5 can be written as 1 by 5. You know, if we are dividing a number, it will be changed into the reciprocal. That is, the whole number 5 is written as 1 by 5. So, we got 1 by 5 into 5, which is equal to 1 by 5 square. I can write 5 power minus 2 as 1 by 5 power 2. Positive exponent. In the same way, 5 power minus 3, 5 power minus 4 can be written by dividing each answer by 5. After that, here another one example is shown for you. 10 power minus 4 is equal to 1 divided by this 10 is written 4 times 10 into 10 into 10 into 10, which is equal to 1 by 10 power 4. 4 times we have written the 10, so it is written as 10 power 4. The negative exponent 10 power minus 4 is written as positive exponent when we are writing in the denominator 1 by 10 power 4. Children, have a rough note with you and please do the following sums in the positive exponent. That is 7 power minus 3, 3 power minus 3, 5 power minus 3 in the positive exponent as given in the previous examples. Okay, children, I think you all remember the multiplicative inverse which we have learnt in the rational numbers. Can you tell me what is the multiplicative inverse of 5 power minus 3? Yeah, it is 5 power 3. When writing as a fractional number, we will get as 5 power 3. Children, in class 7, we studied laws of exponents for positive exponents. Let us now find out whether the same laws are applicable for negative exponents as well. We have learnt 5 laws of exponent. I think you all remember. The first one, a power m into a power n equal to a power m plus n. If it is in multiplication, in the power we will be having the addition. For example, I have taken a positive exponent 5 power minus 3 into 5 power 6, which is equal to 5 power minus 3 plus 6. Now we have the same base 5 and the exponent is minus 3 and 6. M equal to minus 3, n equal to 6. So we will get 5 power minus 3 plus 6. Be careful in adding the integers. Minus 3 plus 6, we will get 5 power 3. So we got the answer as 5 power 3. The next law of exponent, a power m divided by a power n equal to a power m minus n. If it is division, there we will get the subtraction. That is a power m divided by a power n equal to a power m minus n. I have taken an example as 10 power 2 positive exponent divided by 10 power minus 6 negative exponent. Now we have the same base a equal to 10, which is equal to 10 power 2 minus of minus 6. Already we have minuses in the formula, so that 10 power 2 minus of minus 6, which is equal to 10 power 8. The third law of exponent is a power m the whole power n equal to a power mn. For example, I have taken m equal to 3 and n equal to minus 2. Therefore, a power 3 the whole power minus 2 is equal to a power mn means we should multiply both the numbers. So 3 into minus 2 is equal to minus 6. 3 2s are 6 followed by minus sign. So we got a power minus 6. The fourth law is a power m into b power m. Here we have different base but the powers are same. So ab whole power m. For example, I have taken m as minus 3 and the base as a and b. So a power minus 3 and b power minus 3, which in turn multiplied, we will get ab power minus 3. ab whole power minus 3. The last law, a power 0 equal to 1. How is it possible? Yeah, already we know if we take any two numbers, same numbers and divide, we will get the answer as 1. And this is by second law, we will get 3 power minus 5 minus of minus 5. That is, please look at the second step. 3 power minus 5 divided by 3 power minus 5 is nothing but the second law. A power m divided by a power n, which is equal to a power m minus 1. That only I have applied here. So 3 power minus 5 minus of 3 power minus 5 is equal to 3 power 0. 5 minus 5 plus 5 is 0. 3 power 0 equal to 1. So any number to the power raised to the power 0 is equal to 1. Normally we will go for a power 0 equal to 1. But it is not applicable for 0 as base. If the base is 0, we will not take for 1. 0. It is the answer is 0 only. 0 power 0 is always 0 only. But for other numbers, if we have a different base other than 0, then we will have the answer as 1. Children, please have some more examples. Take m and n as different numbers, positive and negative numbers, and please work out all the 5 laws of exponents so that it will be easy for you to work out the problem. In the next slide, we are going to see some solved examples based on the laws of exponents. Next, we will see some solved sums using the laws of exponents. First one, express 125 whole power minus 3 as a power with base 5. Children, note the question, it is base 5. So, I have to make this number 125 as the base 5. For that, first we will go for the L division 125 and then we will get 5 power 3. That is 5 into 5 into 5. 5 power 3, the whole power minus 3, which is given in the question. So if the base is same and we have the powers as 3, the whole power minus 3, we can go for the third law, a power m the whole power n is equal to a power m n. That is 5 power 3 into minus 3. The third law of exponent is used here, which will be written as 5 power minus 9. So 5 power minus 9 can be written as 1 by 5 power 9. So as given in the question, with the base 5, we have written as 1 by 5 power 9. The next question, simplify and write in exponential form. The sum is 1 by 8 into 4 power minus 3. One is fractional number and other is a negative exponent number. First, 1 by 8 can be written as 1 by 2 power 3. Take L division for 8, you will get 2 power 3. After that, into 4 power minus 3. Where 1 by 2 power 3 can be written as 2 power minus 3. So, I have written 2 into 4 power, the whole power minus 3. 2 power minus 3 into 4 power minus 3 will become as 2 into whole power minus 3. where if we do the multiplication, 2 into 4 will become as 8 power minus 3. Children, 8 power minus 3 can be written as 1 by 8 power 3, which is equal to, this 8 can be written as 2 power 3. Again, I am stressing this number 8 can be written as 2 power 3, and again one more power is here, 3, that can be written as whole power 3. 8 can be written as 2 power 3, and the 3 is already there, that is whole power 3. So 1 by 2 power 3 whole power 3 can be written as 1 by 2 power 9. The power 3's are multiplied. A power m, the whole power n. Third law is used here. That is a power m into n. We got 1 by 2 power 9. Children, next we will see the third sum given here. Find x so that minus 6 whole power x plus 1 into minus 6 whole power 5 equal to minus 6 whole power 8. In the given exponent, we have to find the value of x. How to find out that? Okay. First, you write the sum what is given. Minus 6 whole power x plus 1 into minus 6 whole power 5 equal to minus 6 whole power 8. After that, you can see that the first law can be applied here. What is the first law? A power m into a power n equal to a power m plus n. Here a is minus 6. Base are same. So I can write this as minus 6 whole power m plus n. X plus 1 plus 5, which I have written as x plus 1 plus 5. I have used the first law of exponent, which is equal to minus 6 whole power 8, which is given in the question. Okay. First I have written this using the first law of exponent, and this as it is given. Since the bases are same, we can equate the exponents. We have the base as minus 6. That is, if the bases are same on both the sides, after equal to, before equal to, if the bases are same, we can equate and find out the solution for x. I am going to equate the powers. What is the power here? X plus 1 plus 5, that I have written in the left hand side, equal to, what is the power here? 8, equal to 8. I have taken only the powers Kana because the base is same. I have left the base and taken only the powers. X plus 1 plus 5 equal to 8. Where now we should use the algebraic expression form. We have the algebraic equation. How to find out the x value? X plus 6 is equal to 8. Where x is equal to 8 minus 6. That is x is equal to 2. We got the value of x. Next sum. Find the value of 4 by 5 whole power minus 3. It is a negative exponent. We want to find the value. How to find out? That is, from the exponent, we want a fractional number or a whole number. Let me see what we are getting. First take 4 by 5 whole power minus 3. Now apply the power minus 3 for the numerator and denominator. 4 power minus 3 by 5 power minus 3. Okay. Now children, look this, you can observe 4 power minus 3 can be written as 4 power 3 in the denominator, and 5 power minus 3 can be written as 5 power 3 in the numerator. You can work out and see Kanna, that is, express this as this 4 power minus 3 as 1 by 4 power 3, which is written as 1 by 4 power 3 here, and 5 power minus 3 you can write as 5 power 3 in the numerator. You can work out and see, so that we are getting 5 power 3 by 4 power 3, which is equal to, what is 5 power 3? 3 times you should multiply 5, you will get 125. The same way 4 power 3 you should multiply 3 times the 4, you will get 64. We got a fractional value. Now the value of 4 by 5 whole power minus 3 is 125 by 64. Next, we will see how to express a number in a standard form. What is the size of the bacteria, children? It is about 0.0000007 millimeter. Really difficult to tell this number, no? Okay. What is the diameter of the earth? The diameter of the earth is 1 crore 27 lakh 56,000 meter. Abba, really great. These numbers are not convenient to read and write. Numbers which are very big or very small can be written in their standard form. That is, every number, big or small, can be expressed as the product of two numbers. The first is between 1 and 10, and the second is a power of 10. For example, we'll go for the size of the bacteria. This can be written as, that is 0.0000007 millimeter can be written as 7 into 10 to the power minus 7 millimeter. How? Move 7 digits right and write the power with the negative sign. Children, observe here. I want one number as a whole number into the exponent, that is in the power form. So the 0.0000007 can be written as 7. First I have written the number 7 where I am moving the point to the that is the point moves to the right. So what you will get, first I have pointed here where the point is. You can observe here. Now I am going to move to the right. 1, 2, 3, 4, 5, 6, 7. That is, after 7, I can write this as 7 into 10 to the power minus sign, minus 7. If I move to the right, I'll write the power as negative sign. Okay, so the number 7 into 10 power minus 7, I am moving 7 places to right side of the number. This is for the size of the bacteria. Okay, next we will go for the diameter of the earth. How to find out that? This can be written as, that is 1 crore 27 lakh 56,000 meter can be written as 1.2756 into 10 to the power 7 meter. How? Move 7 digits left and write the power with the positive sign. Here we have to move the power to the, that is digits to the left. From here you can start 0, 0, 0. That is 3 digits we have moved. Then 6, fourth digit, fifth digit, 6, 7. 7 digits left side I have moved so that I can write this as 1 point here, 1.2756. 0 is not necessary after the decimal point, so I have not written the 0 here. 2756 into 10 to the power 7. How many digits I have moved here? 1, 2, 3, 4, 5, 6, 7. So 7 digits I have moved, as I want only one number, whole number before the decimal point, which is shown here. So 1.2756 into 10 power 7, that is in the positive sign meter, moves 7 digits left. Be careful in moving the digits, Kanna. There only you will make the careless mistake. If it is 0.000007, you can go for the right. The point can be moved to the right to reach the whole number. And if you want to move left, come to the left and write 1.2756 as mentioned here. Okay. Now, for example, suppose there are this much of stars in the Milky Way. Express this number in the standard form. Please observe the previous example and you can work out in your rough note. Next, we will see some solved sums to express the numbers in the standard form and in the decimal form. First, write the following in the decimal form. 6.04 into 10 power minus 6. This is in the standard form. We have to write in the decimal form. First step, 6.04 into 1 by 10 power 6. I have written 10 power minus 6 as a positive exponent as 1 by 10 power 6. 10 power 6 can be written as 10 lakh. Why I have written like this? To keep the decimal point, I have written 10 power 6 as 10 lakh. After that, for 6 zeros, I have to move the decimal point before 6, 5 digits I have to move. That is totally 6 digits I have to move, including 6. I have to move 6 digits. So first you have to write 604 as it is, and then now start counting the zeros. 1, 2, 3, 4, 5, 6 zeros are here. So you should keep the point before 6 digits. Already 6 is here. So 5 zeros are needed to keep the point before 6 digits. So we'll get the answer as 0.00000604, where we got the decimal form from the standard form. The next sum, 32.15 into 10 to the power 3. The first method, you have to express 10 power 3 as 1000. Why we are doing this? For the convenience of keeping the decimal point. 32.15. In the multiplication, we have to move the decimal point to the right side. We have 3 zeros, so keep the decimal point right to the right after 3 digits. Already we have only 2 digits here, so add 1 0 to keep the point after 3 digits. 1, 2, third digit is 0. Keep the decimal point after this. So we got 32,150. The second sum, write the following in the standard form. How to write in the standard form? Given decimal number 0.0167. Children, please recall the example sum. Size of the bacteria. That is, first we need to write only one whole number before the decimal point. That is the procedure for writing in the exponent form. So how to write only one whole number? The decimal point is before 2 digits. So move to the right. Always move to the right. When we have 0.016, we want only one whole number. Move to the right side. How many digits? 1, 2 digits. So we will get 1.67 into 10 to the power minus 2. Why we are getting minus 2? Because we are moving the point 2 digits after. 1, 2. 2 digits after, and we are getting 1.67 into 10 to the power minus 2. Children, please note that if we move to the right, we have to mention the negative sign. If we are moving to the left, we need to write in the positive sign. Here we are moving to the right, so we are writing in the negative sign. We got 1.67 into 10 to the power minus 2. Second sum, 3512769. Where is the decimal point here? Yeah, it is after 9 only. It is not given here. We should assume it is after 9. Now, in the standard form, I told you already, we need only one whole number part. So, after that, decimal part. How to mention that? How many digits we should move to separate the whole number and the decimal number? Start from 9. 1, 2, 3, 4, 5, 6. We have to move 6 digits to the left and make this 3 as only one whole number. 3.512769. How many digits we have moved? 6 digits we moved to keep the decimal point. So we have to write the exponent as 10 power 6. 3.512769 into 10 power 6. We have moved to the left side so that the exponent will be in the positive 10 power 6. The last sum 0.000102. The decimal number is given. How to represent this number in the standard form? I told you only one whole number part we have. It lies between 1 and 10. We have to move to the right, the point to the right side. That is how many digits we have to move? 1, 2, 3, 4 digits we have to move to keep the point after 1. As we move to the right side, we have to represent the exponent in the negative sign. How many digits we are moving? 4 digits. So we will be having 10 power minus 4. 1.02 into 10 power minus 4. Children, you can work out all these sums roughly on your own so that you will be very clear. And I have given the sums in the worksheet based on the standard form and decimal form. So you will be very clear in that. First you go for the recap worksheet which you have already learnt in the 7th standard, and then you go for the exponents worksheet which is for 8th standard. Jai Gurudev. Thank you children.